Hello everyone and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Material Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you needed any help with homework or with tutoring, then check out the links in the description below. Now let's just get started on our set of questions for today's session. Okay, so question 1 asks if HCl is polar or nonpolar. Okay, so let's draw the Lewis structure of hydrochloric acid. Hydrogen has 1 valence electron, and chlorine has 7. So in total, we have 8 valence electrons for this compound. So this will help us determine our Lewis structure. So if we drew a single bond between hydrogen and chlorine, and then also added all of the lone pairs on the chlorine, and counted how many electrons we've had so far, where each bond contains 2 bonding electrons, you can see that we have our 8 electrons already drawn. So now we just need to determine whether or not this bond is polar or nonpolar. So what we need to do is we need to look up the different electronegativity values for both hydrogen and chlorine and see their difference to determine whether or not the bond is polar or nonpolar. Okay, so the difference in electronegativity between hydrogen and chlorine. So chlorine has an electronegativity difference or electronegativity value of 3.0, and hydrogen's is 2.1. Okay, so the difference between the two is 0.9. So therefore, we know this bond is polar, and this is because our difference in electronegativity is greater than 0.4, but less than 1.67. So on our Lewis structure, we can show a dipole moment that goes towards our chlorine like so. And it is this difference in electronegativity that makes our compound polar. So this is because our hydrogen has a partially positive side and our chlorine has a partially negative side. So this makes our molecule polar because we have a non-zero net dipole moment. Okay, so let's see what the junior tutor said. The covalent bonds become polar because of the electronegativity difference between the elements involved. Electronegativity difference causes the electrons in the bond to be unequally shared. This results in a partial positive charge on the less electronegative element and a partial negative charge on the more electronegative element involved in the bond. The charge separation with the partial positive charge on one element and partial negative charge on the other generates a dipole moment, which is a vector quantity. All the polar bonds have a dipole moment, and the direction of the dipole moment is from the partial positive charge to the partial negative charge. other words, the polarity of a bond is explained by its dipole moment. Okay, so they showed how to calculate dipole moment, which is the product of electronic charge and distance separation of the charge. Molecule is a polar if the vector addition of the dipole moments of all the bonds present in it is non-zero. So the electronegativity of chlorine and hydrogen are 3 and 2.2 on Pauling's electronegativity scale. The electronegativity difference between chlorine and hydrogen suggests that the bonding electrons are unequally shared, and they are lenient towards a more electronegative atom, such as chlorine. Okay. So it implies that HCl has a dipole with a non-zero dipole moment, therefore it is polar. And they also drew the vector towards the more electronegative chlorine. So this solution is correct.